250 million years in the future, planet Earth is unrecognizable. The 7 continents are now one giant landmass, a supercontinent of vast and arid deserts.
It's incredibly hostile, incredibly unpleasant. This is a very nasty land.
Surrounded by a global superocean, packing terrifying storms.
It'd be difficult to actually tell where the ocean ended and the atmosphere began.
This strange new world will transform geography, the climate, even life itself. Earth may be on a collision course toward disaster. Today, life on Earth is good. Our planet enjoys a moderate environment with few true extremes. The main reason for this is the layout of Earth's landmasses and oceans. The major continents run north to south. There are nearly 2,000 islands separated by 3 major oceans, which balances temperatures and provides conditions for life to flourish. But that won't last forever. Scientists predict that all Earth's landmasses will combine to make one giant supercontinent. This supercontinent will trigger a domino effect that could threaten all Earth's systems. And consequences for the planet could be apocalyptic. Earth's fate hangs on the precise shape of this coming supercontinent. Geographer Chris Scatese is a leader in the race to determine the future formation of Earth's continents.
What forced me to think about the principles, the driving mechanisms of plate tectonics, how plates evolve and how the system behaves.
For Scatese, many clues are in today's continental layout.
The key is to look for the seeds of things that may evolve and develop into the future.
And there are other clues. In the past, Earth was a supercontinent before. 250 million years ago, all landmasses were joined in the supercontinent Pangaea. Recent research reveals surprises about how Earth's landmasses moved in the past. Traditionally, scientists used geology and fossils to reconstruct the shape of the Earth millions of years ago. But in 2007, evolutionary biologist Gonzalo Giribet revealed a different tack. He found a living creature that holds in its DNA a record of the journeys the continents have traveled around the planet. The mite harvestman is an ancient species found on every continent except Antarctica. The tiny bug can travel a range of 50 miles. 6 years of field trips and many thousands of harvestmen later, Giribet extracted DNA. He built an evolutionary tree of origin, dating back almost 300 million years. He discovered related species that today are separated by thousands of miles of ocean. Giribet's research confirms recent findings about the shape of Earth's last supercontinent. He was puzzled by the DNA of the Florida mite harvestman. It showed no connection with other North American species. But it was related to mite harvestmen thousands of miles away in West Africa and South America. This little bug revealed a new detail about Pangaea.
The form part of this kind of cleavage between South America and Africa.
Florida was once part of Africa when Pangaea broke apart it drifted west to join North America.
It's how we come about to have a relationship between animals that now live in West Africa, in tropical South America, and in Florida.
Such details help Chris Scatese refine his map of the future. But first, he had to predict the movement of the giant interlocking pieces of rock that cover Earth's surface. These tectonic plates float on a superheated layer called the mantle, the engine that drives the plates around the planet. These plates constantly rift apart, so the continents move like pieces of a giant slide puzzle. A second process brings the landmasses together into a supercontinent. Subduction. When two plates of different densities collide, heavier oceanic rock sinks or subducts beneath lighter rock. And when subducted by continental rock, ocean basins slowly vanish and continents collide. Scientists call this the Wilson cycle. Data from sites like McDonald Observatory in the Davis Mountains of West Texas allow scientists to measure the speed and direction of Earth's tectonic plates. 43 sites like McDonald beam lasers to a satellite. Hundreds of reflectors bounce the beams back. It's a technique called satellite laser ranging. Scientists then calculate the distance between the satellite and each ranging site. Their measurements are accurate within tenths of an inch.
It was unimaginable that we'd be able to make these precise distance measurements, which allows us to measure these very tiny velocities on a human timescale, millimeters a year, measured over years or decades. Just blows my mind.
Gordon plots this data onto a map.
Here's a world map indicating the relative velocities. So it's highest here in the Pacific, where it gets as fast as 140 millimeters per year.
The reason for this high speed is a plate boundary in the eastern Pacific. Magma emerges at this boundary, creating new seafloor that spreads up to 4 inches a year. But it's being subducted faster than it's being generated. Chris Scatese drew together all the data for his prediction. The result was a world map unlike any we know today. And he was a little surprised.
When I put the continents together in this configuration, it was obvious it's sort of a circular continent with a hole in the middle. I said, what am I going to call this thing? Donutia? Or maybe it looks like a bagel, Bagelia?
250 million years from now, and our planet is barely recognizable. There's just one landmass, a spectacular supercontinent, 13,000 miles long and wide, with one global superocean that covers 2/3 of the planet.
What we see is a ring of continents surrounding the remnants of the Indian Ocean that lies right on the equator.
North America collides with southern Africa, closing the Atlantic Ocean. Antarctica moves north to join with Southeast Asia and South America. Scatese has a name for his vision.
We came up with Pangaea Proxima, which literally means the next Pangaea, because it's clear plate tectonics will continue, and there'll be other Pangaeas in the future.
And the journey to Scatese's vision of the future promises to be a white-knuckle ride. "50 million years in the future, our planet's landmasses are on a collision course. The evidence for this future mega-collision is already obvious today. Chris Scatese thinks subduction zones are the key players that will reshape our world. This is the Ring of Fire, almost 25,000 miles of subduction zones that circle the Pacific Ocean. Most of the world's major volcanoes and largest earthquakes occur here. It was a small subduction zone where the Indian plate descended under the Burma plate, generating a magnitude 9 earthquake in December 2004. This Asian tsunami killed 280,000 people around the Indian Ocean. Ever since the last Pangea, the Ring of Fire subduction zones have driven Earth's tectonic activity. Skatees believes this will change.
This subduction zone has been there for 300 million years. It's a very stable feature. But every once in a while, it spawns off little viruses of subduction zones, and these subduction zones invade another oceans and start subduction in a totally different ocean.
The Puerto Rico Trench in the Caribbean is one such example. Skatees predicts it will play a key role in the formation of Earth's next supercontinent.
Now, this subduction zone is currently in the Atlantic, but it started out in the Pacific and it sort of migrated its way, eaten its way through Atlantic Ocean.
What the subduction zone does in the Atlantic is what matters.
The key is that this subduction zone has the possibility of spreading north and south along the margins of North America and South America, creating a new subduction zone in the Atlantic.
150 million years from now, and this is the new Earth with the startling new Ring of Fire. The Atlantic Ring of Fire will stretch the entire length of the eastern seaboard of the Americas, from New York to Buenos Aires. It will continue along the coast of Antarctica and Australia and loop back across the Indian Ocean to South Africa. Earthquakes will be as common here as they come, and a new chain of volcanoes will explode. This new Ring of Fire will spell the beginning of the end for the Atlantic Ocean.
Well, this is something I call plate tectonics in a box. Basically, it shows a spreading ridge where ocean is created, and we have a new subduction zone along the east coast of North America.
Today, the ridge creates new seafloor, making the Atlantic wider. 150 million years from now, the new subduction zone that runs down the eastern seaboard of the Americas will change all that.
That subduction zone will tug on the oceanic plate, where eventually the ridge gets closer and closer, and actually it's subducted itself. When it's subducted, the subduction zone will be subducting ocean floor attached to Africa, pulling these continents back together.
The last time Earth's continents were connected, it was home to some of the largest creatures ever to walk this planet. But on the next Pangea, it could be the smaller ones who reign supreme.
In the future Pangea, it may very well be that reptiles like this gecko end up inheriting the Earth.
And while Earth's last supercontinent saw the rise of these giant creatures, it also witnessed their demise. Adaptation and evolution could allow some creatures to survive on the new Pangea, but the odds aren't good. The last Pangea was the scene of Earth's largest mass extinction. Could the next Pangea bring on another? $252 million years ago, the last Pangea experienced the greatest mass extinction event in our planet's history. 95% of all life on land, sea, and air was extinguished. It's known as the Great Dying. Paul Wignall, professor of paleoenvironments at Leeds University in England, is fascinated by this ancient murder mystery.
Investigating a mass extinction is really like being a homicide detective, but a homicide detective on a vast scale, a mass murder we're trying to find the evidence for. And so we're kind of looking for a smoking gun, some sort of big clue.
Wignall believes the killer will strike again when the Earth returns to a single supercontinent. Greenland, 1997. Wignall searches for the cause of the Great Dying. He uncovers fossils of what he identifies as marine victims of this apocalyptic extinction event.
What we could actually see there was the detailed story of the loss of various creatures living on the sea floor as the things were dropping out one by one until eventually there was nothing left there.
The presence of unusual quantities of golden-colored crystals of the mineral pyrite points to the likely killer.
This only forms in the absence of oxygen, so this was telling us that here was real clear evidence that the oceans and the seas at this time lacked oxygen, and so life in the oceans simply suffocated, and so they died off in huge numbers.
But what would have caused this extreme lack of oxygen? There are many theories, but the extinction coincides with a massive outpouring of lava 250 million years ago. Scientists call this eruption the Siberian Traps. About 500,000 cubic miles of lava spills out onto the surface of Pangaea. Is this the trigger for the mass extinction? Wignall believes so. The eruption is 1.5 million times larger than that of Mount St. Helens. Lava covers an area half the size of the US to a depth of over 3,200 feet. The eruption releases deadly sulfur dioxide, carbon dioxide, up to 10 times the levels of today into the atmosphere. A cascade effect begins. Carbon dioxide blankets the planet and triggers a massive heat wave on land and in the oceans. Most of the marine life dies, and this is only the start. Bacteria from the seabed thrive in the low oxygen conditions. They generate lethal hydrogen sulfide gas.
If it gets into the atmosphere as well, it makes it even worse for life on land. It's already struggling because of the high temperatures, and now it essentially is having difficulty in breathing because this is a very poisonous gas.
The eruption of the Siberian Traps leaves the oceans almost entirely dead. Life on land is devastated by the extreme climate changes and the poisonous gases in the atmosphere. Could life be taken almost to the brink of total extinction again on a future Pangaea? Wignall believes the devastating eruption of the Siberian Traps was an inevitable and deadly consequence of Earth being a supercontinent. When subduction zones drive the continents together, the result is me. Once a supercontinent forms, subduction stops, effectively capping the volcanoes. And yet heat and pressure from the mantle continue to rise.
I'm sure in the future we'll get these huge eruptions again like the Siberian Traps, and we'll see the same sort of mass extinction happening again.
Such a massive eruption on a future single landmass could wipe out 95% of life on Earth. This was what happened on the last Pangaea 252 million years ago. But life continued, evolved, and came to prosper again across the planet. Now a new theory suggests that next time may be different. Climate scientist Ken Caldera believes that a future supercontinent could destroy Earth's natural ecosystem.
Let me draw a graph to show you how the formation of a supercontinent can trigger the end of life on this planet.
Caldera plots carbon dioxide levels into the future as we face a catastrophic tipping point.
There's a critical threshold for the survival of plants, and that's around 150 parts per million.
Carbon dioxide levels will sink below this life-sustaining level when two natural processes combine. First, as our sun slowly heats up over millions of years, our planet will get hotter. This increases rainfall and weathering, which causes carbon dioxide in the atmosphere to fall.
So that might look something like this.
Carbon dioxide levels also change dramatically over the next 500 million years. When the landmasses begin the journey towards a single supercontinent, subduction between the tectonic plates causes more volcanic activity. The result is higher levels of carbon dioxide in the atmosphere. As the continents collide, they push up new mountain ranges. Warm air rises over mountains and cools. This moisture condenses into clouds and rain. Carbon dioxide dissolves in the moisture to form a carbonic acid that reacts with the minerals in the rock. This breaks down carbon dioxide, so atmospheric levels fall.
With the supercontinent cycles, we expect to see an oscillation in atmospheric CO2 around that general declining trend, and eventually, boom. At that point, the plants will go extinct, the animals that eat them will go extinct, and essentially life on this planet will be over.
Without life, the Earth's natural equilibrium is lost. But volcanic activity continues, and carbon dioxide builds up unchecked in the atmosphere. A runaway greenhouse effect causes temperatures to soar. The oceans evaporate and are lost to space. Our planet becomes as dry and barren as Venus, with surface temperatures almost 932 degrees Fahrenheit, hot enough to melt lead. This may not happen on the supercontinent 250 million years in the future. But this Earth will be a place of terrifying extremes. For millions of years, the continents have drifted around the globe, coming together, breaking apart, and coming together again. A long journey that may just lead to a planet void of life.